Hi, this is Math 2510, and this video is going to be over section 7.5. We're going to look at inverse trig functions. And this is the last section of this course, so I'll try to do this in one video. We're going to look at the different inverses and how we even find the derivative of an inverse of a trig function. So first, let's start with sine. We look at the sine graph. Sine is a function itself, but if we look at it, we notice it doesn't pass the horizontal line test. Sine does keep going as you go through. And so in order to have an inverse for it, we have to section it off or restrict the domain. And so what we want to make sure that both positive and negative parts of sine are within the come out in the domain, and it's best if we can do it without having the domain jump at all, if we can. So for this, we're going to restrict it from negative pi over 2 pi over 2. Now we have something, and I can zoom in on it. I also want to change this to 2 pi, and step will be, let's do pi over 4. Just so we get pi's on here and we can see. Right, so this is going from negative pi over 2 to pi over 2. We see that goes from, the range goes from negative 1 to 1, which is the range of sine. So we have everything involved in sine. And so, so originally, the y equals sine does not have an inverse. And it's because it's not 1 to 1. And a horizontal line basically goes through and intersects them in multiple points. Right, so we restrict the domain in multiple places. And we restrict the domain, so that is 1 to 1. And so we get something that looks like this. It's not a straight line. The sine does have a curve to it. But you end up with the domain here, restrict the domain, negative pi over 2, pi over 2. And your range will go from negative 1 to 1. Okay. The inverse of sine then is inverse sine of x, or we can call it arc sine of x. And so if we wanted to graph that, we see what that looks like. Here are values, our range is going to switch. So your range is now negative pi over 2, pi over 2. And your domain is now negative 1 to 1. You can see here, we'll do it this way. Oh, actually, that showed up. Negative 1, negative pi over 2. Okay, those two are kind of linked. This 1 to pi over 2. Okay. And so we can draw this in this case then. Negative 1, pi over 2, negative pi over 2. It goes like this. Actually, the bend differently in this way. Notice this is a function. Now it passes the vertical line test. And we can think of this as, think of the arc sine or inverse sine of x as the angle whose sine is x. If you think about it, we see on this -1 is negative pi over 2. The angle is negative pi over 2. You get the answer of -1 for sine x. If it was pi over 2, you would get 1. If it was 0, you get 0. Okay. Those 3 points align with both of these. It's just your angle is now on your y-axis instead of being on your x-axis. Okay. And so everything is just kind of reversed with the graph. Right, so everyone know the arc sine of 1? Well, we get pi over 2. If you want to know the arc sine of 1/2, well, this is the same thing as having sine theta equaling 1/2. That happens at pi over 6. If we want to find cosine of the arc sine of negative pi over square root of 3 over 2, but this is the same thing as cosine. We will look at this as sine of theta equaling negative square root of 3 over 2. We're trying to find the theta that we're going to take the cosine of. Is basically what that is happening there. Right, negative 3 over 2. Let's see. A regular 3 over 2 is when you are at pi over 3. So a negative square root of 3 over 2 is going to be a negative pi over 3. You're in the fourth quadrant there. Okay, this is fourth quadrant. As of the domain, it's either going to be in the first quadrant or the fourth quadrant. Cosine in that quadrant is always positive in the fourth quadrant. So we're going to end up with cosine of negative pi over 3, which is going to be just 1/2. And then the last one, sine of 3 pi over 4. Well, sine of 3 pi over 4 is in the second quadrant. We can do sine of 3 pi over 4. That's not a problem. You'll get square root of 2 over 2. But when you do inverse sine of square root of 2 over 2, you won't get 3 pi over 4 back. It's outside of the domain. You actually get back pi over 4. Okay. And that's why the calculators, if you do certain things like that, you won't get back the angle in a third quadrant or in a second quadrant in this case, because the domain for the inverse does not give you those quadrants. It's only going to give you the quadrants that the domain is for. In sine's case, it's quadrants 1 and 4. So what have we looked at? Cosine. Well, we're going just from, let's say, 0 to 5. Let's do 0, 7. It wants it in terms of pi, I forgot. So let's do pi. I see what's going on. Okay. So this is your cosine graph. Notice even this section is still not within the does not pass the horizontal line test. So we even have to restrict this further. But cosine is basically sine, but it just is shifted some. Right. So what we want to do is we want to restrict it from here to here. So from 0 to pi. And that gives us something that does pass the horizontal line test. And then if we look at the inverse of this, it's like that, where this top point is -1 pi. And this bottom point is 1, 0. And that middle point is 0 pi over 2. It comes down this, and you have your inverse. Okay. So the restricted domain for cosine is from 0 to pi. This is the first and second quadrants. It's negative in the second quadrant and positive in the first quadrant. And the range is -1 to 1. The domain here would be from -1 to 1, but the range goes from 0 to pi. Okay, that just reversed. We can look at tangent, which is tangent here. And we'll do this from -2 pi to 2 pi to start with. So we see them with this one, doesn't pass a horizontal line test, so it's not going to be a one-to-one function. We do have to restrict it, and what we want to do is we want to restrict it between the asymptotes. So we're going to restrict it from, similar to sine, -pi over 2 to pi over 2. We get just one section of that. Okay. Here's your asymptotes. It's just the tangent graph. Between those, the range goes from -infinity to infinity. It just keeps going higher and higher and lower. Let's see here. And then the domain is between your asymptotes, -pi over 2 to pi over 2. So these have to switch. Range is -pi over 2 to pi over 2. Domain is -infinity to infinity. And when we look at the arctangent, that's what's happening. You get your at horizontal asymptotes that are at -pi over 2, pi over 2. Do it this way. Y equals pi over 2. And we see it goes right up to that green line. Pretty quickly too. And then we do -pi over 2. Goes right down to that green line on the other side. So here you have instead horizontal asymptotes. And the graph looks like this. Right. So we'll go through again. Domain for sine or arc sine was the range for sine, so -1 to 1, and the range was -2 pi/2. Okay. That's where the sine is restricted. Cosine, the domain was -1 to 1, and the domain for cosine was restricted to 0 to pi. This is first and second quadrants, first and fourth quadrants. Arc tangent was infinity to infinity. And the range, which is where the tangent was restricted, was -pi/2 to pi/2. This again is the first and the fourth quadrants. Right. So arc cosecant, arc secant, arc cotangent. To find these, not sure how easy they would be to graph. Let's try one. That's cosecant. And then this is, see if this works. That works. Okay. So again, we're trying to get the spots in. We do go over the asymptotes because just the way secant and cosecant work. So for cosecant gets restricted from -pi/2, pi/2, just like the sine, because we kind of do have to restrict it the same as the sine. And so its domain for arc cosecant is -infinity to 1, union with 1 to infinity. The blue one is arc. So we see it starts out at 1, then it keeps going to infinity. This side starts out at -1, goes to infinity. And then your range is between the -pi/2 and pi/2. We actually, it's still technically not allowed at 0. We can adjust the range a little bit. 0 and 0 to pi/2. Okay. But it's the first and fourth quadrant, just like sine. Secant, we see it looks like that. Okay. Now, even though that seems to be all of the secant, we want to restrict this 0 to pi, just like cosine. So this is where the restriction happens. And so our range is from you'll go from 0 to pi. You do have a horizontal asymptote though at pi/2. That'll be 0 to pi/2. union pi over 2 to 0. And then for the arc secant, we're going from, again, negative infinity to negative 1, union with 1 to infinity. And this is first and second quadrant, just like cosine. And then cotangent is really just kind of tangent curved. The domain for arc cotangent is infinity to infinity, just like tangent, arctangent. And it goes from let's see, 0 to about pi, which would be first and second quadrants. All right, so we'll go through some of these. Arc cosine of 0, or the angle that gives you 0 is going to be pi over 2 for cosine. So that would be equal to pi over 2. Arc tangent of 1, that's going to be pi over 4 because tangent of pi over 4 is 1. Arc secant of negative square root of 2. For these, I always tend to look back at what cosine would be. This would be a negative 1 over square root of 2, which can be written as negative square root of 2 over 2, which is going to put you in the the second quadrant. That's why cosine's negative. That's going to be 3 pi over 4. Right, so we'll do the tangent of arc cosine of negative square root of 2 over 2. This is the same thing as, again, tangent of 3 pi over 4, which is going to be equal to negative 1. We look at arctangent of negative pi over 3. Well, tangent is first and fourth quadrants. So this is going to be, pi over 3 is your pi over 6. This is going to be a negative pi over, square root of 3 is going to be a pi over 3. So negative pi over 3. The cosine of negative pi over 3, again, it's negative. It's going to put us into the second quadrant because it's cosine. And that's going to be your 60 degrees there, which is cosine goes from 0 to negative 1/2. This is going to be negative 1/2 here. And then arc cosecant of 2 over square root of 3. We'll look at this as arc sine of square root of 3 over 2. And that's going to be, and we're taking the cosine of it, that's going to be square root of 3 over 2. The angle for that is pi over 3. That's going to give you 1/2 when you take the cosine of pi over 3. And this last one, cotangent of arc sine. We can write cotangent as cosine over sine. It's going to be over the arc sine over the arc sine. The bottom one's going to give you x. So you have cosine of arc sine of x over x. Can't go anywhere from there. Right, so cosine of arc cotangent 4. Now, these aren't ones that would fall on a unit circle, so we have to use some kind of calculating device. For this, we can just type it in, cosine of cotangent inverse of x, well, of 4, and you get 0.970. And then if we did sine of arc secant 3, sine secant 3, you get 0.943. These are, of course, in radians. Right, so now let's get to the derivatives of inverse functions. A couple things to remember. Sine inverse and sine of x gives you x. Sine of sine inverse also gives you x. That's because we are between, they are inverses of each other, so they should give you x. And then we're going to use implicit differentiation to do this. So, other thing to remember, we're going to start with sine squared x plus cosine squared x equals 1. We'll draw a little triangle here. X and y and 1. Right, so sine y is sine of sine inverse of x. Just put x. Okay. We're starting with the idea that y equals inverse sine of x, and we're taking the sine on both sides. Okay. So I'm starting here, and I go here by taking the sine on both sides. Then I'll get sine y equals x. Okay. Now I'll apply a derivative. Now we apply a derivative. I'll get cosine y prime equals 1. Right. And so I'll solve for y prime, get 1 over cosine y. And then this is where we bring back, we use this triangle. We'll have x squared plus y squared equals 1. And we can write this as sine squared x plus cosine squared y equals 1. So cosine squared y equals 1 minus sine squared x. When we take the square root, we get cosine y equals square root 1 minus sine squared x. And we can write this as square root of 1 minus x squared. So this becomes 1 over square root 1 minus x squared. Okay, that ends up being your derivative of your inverse sine. So derivative of inverse sine. Good thing about this is all the derivatives look very similar. We're not going to go through them all. But your derivative of inverse cosine is just the negative of what we got for inverse sine. Derivative of tangent is 1 over 1 plus x squared. And the derivative of cotangent is the negative of that. So negative 1 over 1 plus x squared. Cosecant and secant, there's a absolute value of x in the bottom. You have to take that into account. But it also is very similar to what derivative of sine and cosine were. The other thing is you have to apply the chain rule when you're not just dealing with the inverse sine of x, but you're dealing with like 1/4 x. So when we're going to have 1 over x. So let's do these examples. We have y equals inverse sine of 1/4 x. That means we're going to have 1 over square root, since this is inverse sine, 1 minus x over 4 squared. And then derivative of that inside is 1/4. And then we can kind of simplify this out as best as we can. We'll have 1 over 4 square root 1 minus x squared over 16. We'll find a common denominator. 16 over 16 minus x squared over 16. And so this becomes 1 over 4 square root of 16 minus x squared. And you can, well, I'll write this out. You have 16 on the bottom. You can take the square root of that 16 on the bottom, and it'll just give you 4, and that square root cancels out with that 4. So 1 over square root of 16 minus x squared. And that's your derivative of inverse sine of 1/4 x. Tangent, very similar. We'll use the tangent, inverse tangent of formula here. So your inverse would be y prime be 1 over 1 plus x squared, but x is 1/4. Well, I'm sorry, x is 1 over x, so 1 over x squared. Then we're multiplying this by the derivative of 1 over x, which is negative 1 over x squared. Okay, so now it's just kind of simplifying this out. A negative 1 over 1 plus 1 over x squared times squared. And then we can multiply the x squared in. We have x squared plus 1. And that will be your derivative. All right, that's the end of section 7.5 and the end of the notes for Calc 1. And maybe you'll be in Calc 2. We'll see. Take care.